Welcome to Sound ID's demonstration of batch recognition of the Dawn Chorus. We have, first of all, to load in the software, and you'll find that in this little icon over here, the little parrot is the Sound ID icon. You click on that and you bring up the suite of programs that constitute Sound ID. Now, for this particular exercise, we are going to go straight to the batch recognition module, which is probably the most powerful module in the whole Sound ID suite, and we're going to look at analysing a Dawn chorus with about 15 separate callers calling simultaneously, as is normal in a Dawn chorus. So we click on the batch recognition, and up comes the batch recognition module. Now, first thing that's a little bit different about Sound ID is the way we load files. So we'll find our WAV files, which are snippets of recording of a real Dawn chorus. So we go to our folder and we look for our recordings, which happen to be in here and in here. And here we have some quite small ones. It says super small, but they are quite small files because this is a demonstration and we don't want to take too long. We can load dozens, hundreds, or even thousands of files in if we so desire, but this would take a lot longer to run, and we don't want to do that. Now, how do we load the files? Okay, we'll load some more files. Here we're going to load the templates. These are the reference files and contain a list of things that we're looking for. So we go back to the same point, and our reference files are in this folder here. Now we need to open the folder, and then here you will see we've got BB, which is a butcherbird, low and wide. This is because the butcherbird's got two distinct types of calls, one of which is relatively low frequency, below 5 kilohertz, and one of which is wide frequency, from 0 roughly to 10 kilohertz. We've got a crow, we've got a currawong, we've got an eastern whipbird, grey striped thrush, guinea fowl actually in parts of this recording, Lewin's honeyeater, magpie, sedge frog, plover, rainbow lorikeet, rosella, another sedge frog file, and a Mickey bird who's ever persistent in the Dawn chorus where this particular recording was done. Now to open all of these files, we click on one of them. This is how we open our files of any kind. And then we click on open, and then they all load up into this window. You click on one, but it will load everything of that extension in. Now in this case it's a DAT file, which is a reference file. In the case of a WAV file, it's a WAV file. You do not have to highlight all of the files. You just simply click on one of them and it will load the lot in. So we go to the back here, and this is the engine behind the batch program. You needn't normally take too much care with this, but sometimes you need to change things. You might, for example, want to change the detection parameters, which are here, and you might want to change the weighting vector. Most of these factors here are preset, and they are preset in the reference files, and they will automatically line up with the reference files. So you can't change all these ones that are grades. You can't change them. Here it's again, we've loaded in exactly the same files. This happens automatically because this is actually really the engine. The front page is really just copying what this page is doing. So we've got our butcherbird low and butcherbird wide again, and the same list of calls. We've got a default GD of 6, which is fair enough for most calls, but if you have your own calls, which will be different to ours, you may have to determine by other means what that ought to be. So we're not going to change anything here. All the default figures are fine for our purposes. So we can change one thing. We're going to allow the file to play because we want to hear it, as well as watch it processing. Now this is going to happen fairly quickly, so I'll just shut up and let it run. So I'm going to hit this run batch, and then it's going to read this first file, and then, which is a WAV file, a long WAV file, and then it's going to open the second file, and it will process that for all of these different references here. And up here you will see a blue line running along, which actually indicates which one of these files is currently being processed, and as it gets to the end, the last one's being processed. So I'm just going to run it and let you listen to the sound of the Dawn Chorus while it's being processed. There's that blue line showing the process happening of loading the files. And we're done. So it's actually processed those signals and it's extracted. Here's a summary of what it's extracted. 2 magpie calls, 35 eastern whipbird calls, 51 Mickey bird, also known as a noisy miner, and 92 pied butcherbirds. There were 2 files up here, two WAV files, and down here this is the results of each of the WAV files. So we click on the first one, and down here we get the individual results. And each result, for example, let's take this one, is telling us first of all how many seconds in it found the first recognition, which was a pied butcherbird, the peak frequency of it, the size of the file that it was looking at, and how close the match was. 5.42 is not very good, we might go for that one. So if we click it once, double click it, it will actually play the sound. Okay, and it brings up this picture of the signal itself. So I'll do that again. Now that's just too quick for a human to know that that's a pied butcherbird or not a pied butcherbird. And we might want to get rid of that, so you can bring up that if you want. I've just turned it off here. So what we do, we set the buffer, which is how much before and after the part of the call that's being looked at is played. So I've added a bit over 1.1 seconds to the front and the end of that call. So now when I double click it, now you can clearly hear that that's a pied butcherbird. If you know your pied butcherbirds, that's a pied butcherbird. Then we go down to find, here's a bunch of Mickey birds. Now that is clearly a Mickey bird. This batch here is all Mickey birds, and they've occurred about 3 seconds in. So I've actually got here 3.5 seconds, 3.511 seconds, 3.567 seconds. So it's finding the call in very, very tiny little chunks. If we, this is actually only the first file. The second file, same thing happens. You double click on that one, it opens it up, and we play it and we confirm yes, it's a pied butcherbird, and that's what it says it is. These windows here contain the individual matches to the references for this particular file, for the second file. If I click it here, you'll see those numbers there have changed. I'll do it again. Watch up here, and you'll see the changes happening there. And these 2 windows summarize the results from that particular file, whereas this window doesn't change because it's summarizing the results from the whole file. So there it is in a nutshell. That's how fast Sound ID can handle a Dawn Chorus, how quickly it can process it, and it summarizes all the results. And you'll notice that those little export to Excel buttons will send the contents of each of these files here into Excel, so that it's a comma separated variable file, and from that you can record all your results in an Excel form, and you can process them the way you want. There's a lot more we can do with this, but this is meant to be just a brief showing of what we can do and how quickly we can do it. So there you go.